Welcome to my video on Introduction to Quadratic Equations. In this video, I want to go over what is a quadratic equation, give you some examples, and look at some of the properties. So a quadratic function is a function of the form we've got ax squared plus bx plus c, with one requirement here that a does not equal to 0. Then it's no longer a quadratic equation. Where a, b, and c are real numbers, and the domain of the quadratic function consists of all real numbers. So it's basically everything except the complex or some unusual number. Most of the stuff that we're going to see in physics and math is going to be covered under this. The quadratic function is a function defined by a second-degree polynomial of one variable. So what does that mean? Okay, a second-degree polynomial means the unknown is to the second power. That's the x term, so that's x squared. That's the highest power in the polynomial. And it's one variable. We'll only have x as our variable. A and b and c are coefficients. They're constants. So that's what we're talking about. A quadratic function is a function defined by a second-degree polynomial, one variable. So let's look a little bit more into the quadratic equation. So finding the zeros, that's one thing we always want to do, finding the roots of the equation. So that's going to be basically f of x is equal to 0, set it equal to 0. And that's going to be equivalent to finding the x-intercepts of a graph of the function y is equal to f of x. So when the graph, which is going to turn out to be basically a parabolic of some form, crosses the x-axis, that's going to be your zeros, because that's where the value of y goes to 0. So let's look at an example. We want to find the zeros of the function x squared plus 3x plus 2. Now we can factor this out to x plus 1 times x plus 2. Okay, I'm not going to explain factoring right at this moment, but we're going to talk about zeros. But let's just multiply that out using the FOIL method, and I have a video on that too. So first is x squared, so that's that term there, outer plus inner, so that's that, 2x, the inner is x. So we've got 2x plus 1x is 3x, and then we got the last, which is 1 times 2, which gives us the 2 term. So we agree, but we just showed that that's how it expands out. So now let's check this out. So if we write this equation, x plus 1 is equal to 0, and then we do x plus 2 is equal to 0. So if we add minus 1 to both sides, x is equal to minus 1. And so there is our root. Now let's put that back in the equation and see if that works. So minus 1 quantity squared plus 3 times minus 1 plus 2. Okay, that's going to be equal to minus 1 squared is just 1. And then 3 times minus 1 is minus 3 plus 2. Adding those up gives us 0. So that's good, that checks. On this factor, we're going to have x is equal to minus 2, just adding minus 2 to both sides. Now let's stick that back into the quadratic equation. So we get minus 2 quantity squared plus 3 times minus 2 plus 2. What does that equal? So minus 2 squared is 4, and then we've got 3 times minus 2 is minus 6 plus 2. Add those to get 0. Okay, so there we did it mathematically. We factored this quadratic equation, and we found the roots of it, and we showed that the roots where the f of x is equal to 0 was minus 1 and minus 2. Now let's do this graphically. Used to do this is the graphing Desmos calculator, and you get on the graphic function. Now I'm simply going to enter the function and plot it. So it's going to be x squared, that's our first term, and then plus 3x plus 2, plus 2. Okay, so there's our graph. Now let's expand that out and see where that crosses the x-intercept. And it looks like minus 2 and minus 1. So that verifies what we just did mathematically, graphically. So that's good. That's the roots of that equation. So now let's look at the standard form of the quadratic equation. And we just saw that a second ago, but this is called the standard form, where things are put in that. Ax squared plus bx plus c is equal to 0. When you're asked to put an equation in the standard form, that's what that means. And let's look at some examples of that. So we got 3x squared minus 5x plus 2 is equal to 0. In this case, a is 3, b is minus 5, and c is equal to 2. Another example would be minus 6x squared plus 2 is equal to 0. A is equal to minus 6. B is equal to 0 because there is no x term. And C is equal to 2. Another example, 1/2 x squared plus 2/3 x is equal to 0. In this case, A is equal to 1/2. B is equal to 2/3. And C is equal to 0. So there's 3 examples of the quadratic equation. Now, I briefly talked about factoring just a minute ago, but there are going to be 4 methods that we're going to solve these quadratic equations and find the roots. And so the first is factoring. And these are going to be the topics of future videos. And then the second is the square root method, and then completing the square, and then the quadratic equation. And they're all useful methods. Just from my point of view, practical experience, the quadratic equation is the one you'll use the most once you get out of math class and into physics and engineering, or wherever if you're going to go follow this up. That tends to be the most useful. Well, I hope you got something out of this video, learn a little bit about the quadratic equation, and follow my other videos because we're going to go into this in much more depth. Thank you for watching.